And nice to meet you. I'm Chie Hayashida. First of all, I will introduce myself. Hi. I'm a software engineer at Cookpad from Japan. I always develop and contribute to some OSs such as Tensorflow or Apache Spark or Apache Airflow and so on. And sometimes I write articles and make presentations mainly in Japan. So I'm afraid of English. Yes, and this last December, I went to re:Invent 2018. This is AWS largest event, and I joined Game Day, which is performance tuning contest, and my team won first prize. Cookpad. Cookpad is the world's largest recipe sharing platform. I hear that some of you know about Cookpad, so I'm happy to hear that. Please try it to cook your favorite recipes. Cookpad is not only Thailand and Japan. It is used in very many countries about 17 countries and 26 languages. We have 94 million monthly average users. Very big service. But I don't explain about Cookpad after that. Agenda of my session is here. I introduce basic knowledge of concurrent, parallel, and distributed processing in Python. And next, I explain about parallel processing in Python. And finally, I explain about distributed processing in Python. So let's go. This is disclaimer. I talk about basic architecture of parallel and distributed processing library in Python, but I don't talk about how to install and set up each libraries and how to use the API, the detail, because we can easily get knowledge of libraries usage from documents, but basic knowledge of this is not so spread, and there are few documents. So I'd like to introduce about it. So when we use parallel and distributed processing, for example, download large data from internet in short time. Second, use large data for data analysis or machine learning. Or third, handle a lot of requests simultaneously at website. Now, I have a question. Do you know what is the difference of below? Concurrent processing and parallel processing. How many people can explain about it? Oh, very many. Those people don't have to hear about my session. I explain about it. Co-inventor of Golang's Rob Pike says that concurrent is about dealing with a lot of things at once. And parallelism is about doing lots of things at once. So they are not same. One is related to the structure, and the other is related to the execution. It is the image of concurrent and parallel processing. The two tasks are, in concurrent processing, the two tasks are not necessarily performed at the same time, but they cooperate with each other. But in parallel processing, this is below, the two tasks are running at the same time. This is the concurrent and parallel program scheme. In concurrent program, it uses only one core per program. So CPU scheduler will control the process execution use these process queues. But in parallel program, there are no process queues or scheduler. It can use each CPU, one process use one CPU. It is more simple in the image, only in image. Now you know concurrency and parallelism. So next question: what is the difference of parallel processing and distributed processing? Can you explain? Oh, no? Yes. So I'll explain. Parallel processing is mainly for only one machine. So we have 3 processors in this image, and the processors will share the memories. On the other hand, distributed program aims at the possibility of sharing the processing by exchanging data through messaging between machines of computing, which are physically separated. So network will send messages to share the data. This is difference between parallel processing and distributed processing. So when and how should we use parallel and distributed architecture in Python? And this previous talk is about general talk about the distributed processing. Now start to talk about Python's parallel and distributed processing. First of all, I introduce threading and multiprocessing. They are Python's official modules for parallel processing. Python is often said that battery included, as very many people knows. It means that Python itself can use various functions without third-party libraries. What is the difference between threading and multiprocessing? Threading is the module to divide one process into multi-threads. So usually we use only one thread, one process, one thread for our program. But when we use threading module, we can divide the process to threads. But in thread, GIL limits only one thread can be in a state of execution at any point in time in CPython. So Python's threading is in fact not parallel, but is concurrent from aspect of CPU execution. So we can run. It is only one thread is running in same time. So why we use Python use GIL? Threads in process use same memory space. So CPU interpreter does not implement mechanism of synchronization for the concurrent access by threads. GIL was chosen to protect the internal memory used by the interpreter. But it is talk about CPython. When we use JSON or IronPython, there are no GIL. And PEP 554 is proposing a sub-interpreter which obscure GIL. So in fact, situation is threading effective. Tasks which is I/O bound is it. For example, read and write files, DB connection, or download data from network. They don't use CPU so much, but they use I/O, very many I/O. So at this image, await is very long, but I/O bound process can use await state to another process about I/O. This don't use CPU. Threading is very useful if the number of threads is increased, but if the number of threads is carelessly increased, context switch decreases performance. So next, multiprocessing. Multiprocessing spawns processes for parallelization. So how multiprocessing divides one process to sub-processes? Each process has its own memory space. So this is merit. The multiprocessing doesn't affect it by GIL. And multiprocessing is less likely to cause errors due to corruption or deadlock. So because of such a feature, multiprocessing is effective at the task which is CPU bound, such as numerical calculation, matrix manipulations, regular expression processing. They all use CPU. But it's known as Amdahl's law. The performance in Python's multiprocessing doesn't increase linearly. Also, there are several OS functions to achieve multiprocessing. This is a demerit, but Python's multiprocessing uses OS fork function of operating system. OS fork function copies necessary resources such as memory space from parent process to child process. So, for example, when memory size is very big, the parent processes will transfer very large data from parent process to child process, so it costs very high. There are another demerit of multiprocessing. Tasks which can run at the same time is limited to CPU number attached on the machine. So when we run 6 tasks on the machine which has only 2 CPUs run at the first, and after finish, another task will be run. If you try to increase parallelism, you have to increase CPU number of machines. Next, I introduce about Joblib. Joblib is a third-party library for parallel processing in Python. Joblib can use, Joblib's default backend is Loki, which is a third-party parallel architecture, but we can use threading and multiprocessing of Python official for backend too. And Joblib has lazy evaluation function and using transparent disk caching mechanism. So calculations are performed as needed by the output and only when it's changed. Joblib can written and next feature is Joblib can be written very simply and easily than multithreading and multiprocessing. It is truly recommended for users of threading and multiprocessing. Last feature is logging and tracing of the execution. When we run parallel processing, it often occurs that child processes dies and and the study is very difficult. But at Joblib, we can see child processes logs, so it's very useful for debugging. Summary up to here. Python has official module for parallel processing. Threading is effective to I/O-bound processing. Multiprocessing is effective to CPU-bound processing. Both of two are mainly for only for processes run at one machine, so not for cluster, only for local machine. Some of data libraries transparently use these parallel processing libraries. For example, NumPy is multithreaded with BLAS or C implementation. It doesn't use Python's multithreading or multiprocessing, but that use C layers multithreading or C layers multithreading. Or scikit-learn depends on Joblib. So when we use scikit-learn, transparently Joblib is used. Or TensorFlow. We can use TensorFlow on the machine on the CPU. When we use CPU for TensorFlow, TensorFlow will automatically multiprocessed. It is very interesting, I think. So we finally got to distributed processing. It was very long from session started. Please remember about the distributed processing architecture. The parallel processing and distributed processing is different about one machine, for one machine or cluster. Distributed processing is for cluster. Okay, so when we have to use distributed processing, we have to consider about distributed processing when we use very large data which cannot processed in one machine. For example, 100 terabyte or petabyte. It is not run in only one local machine. So there are many distributed processing libraries which can be used from Python, but there are very small time. So I introduced only three libraries. They are all famous libraries in Python. First is Celery. Celery's feature is here. Celery is distributed task queue built in Python, a pure Python library. Celery is very simple and flexible have flexible architecture. We can extend every component of Celery. So we have the Celery's architecture. So we have four components, but we can extend the components to, for example, we can change broker product from RabbitMQ, Redis, SQS, or another products. The another components is same as it. And Celery is very famous and heavily used for task-based workloads in Python. For example, with Django, for example, Airflow's backend. So in what situation is Celery effective? When the task is simple, Celery have very simple architecture. So it is not, the complex task is not fit for Celery. Celery likes very simple task, but Celery can large data which cannot run in local machine. When you want to use, when you try to, when you try to run complex tasks in Celery, it is possible, but we have to write a lot of code for it. It is not recommended. Next is Dask. Dask is a distributed processing framework built in Python. It is pure Python 2. Dask is able to use NumPy, pandas, lists like parallel objects. The Dask scheduler is customizable to get good performance for both for parallel processing and on local machines and for distributed processing on cluster. It has good web interface for real-time job monitoring. Dask scheduler is here. Array is NumPy-like API, and back is list-like API, and data frame is pandas data frame-like API. So when we define them, Dask will automatically create the task graph, and the scheduler will will schedule the task. This is Dask's web interface, a very beautiful interface. And Celery and PySpark has web interface too, but I think Dask and PySpark's UI is better than Celery. In what situation Dask effective? Dask is effective when we want to parallelize NumPy or pandas processing. We can alternate, very easily alternate NumPy or pandas code to Dask processing. And when the data size fits 1 to 4 or 5 machines, Python is not so cost-efficient language, sorry. So we can use distributed processing, but not so many clusters is fitted. Finally is PySpark. Spark is in fact built in Java and has Python interface. PySpark can be more scale out than Celery and Dask. This is PySpark's architecture. When we use we use application, the Python's program will be sent to master node, and the transfer to Java code. And in worker, task is run in Java. This is a scale-out model of PySpark and Dask and Celery. Celery and Dask is from 1 or to 4 or 5 nodes cluster, but PySpark can scale out to thousands nodes. Yes, and PySpark is originally built to run on the Hadoop cluster, and fast and cost-efficient processing because thanks to implementation ideas such as how to use heap memory, lazy evaluation, and so on. PySpark has good web interface. And PySpark has multifunctional API, such as Stream API and Machine Learning API. So PySpark can run very complex tasks in it. PySpark can be used in management service in cloud service. It is very merit of this because cluster maintenance is very heavy task for infrastructure engineer. In what situation is PySpark effective? When we want to run complex task, PySpark is very fit. And very large data we can use in PySpark. When you have a Hadoop cluster already, PySpark is fit for it. Summary. I explained about the difference between concurrent parallel distributed processing. I introduced about the architecture of parallel distributed processing libraries in Python. I couldn't introduce about async I/O, concurrent features, or another third-party libraries, but sorry, but you can learn. So finally, what I'd like to say is here. Don't be afraid to use parallel processing and distributed processing more. If you have a question, there are 3 minutes.